12.2 we're going to be graphing exponential functions, and the book does it a little differently. They go like a to the x, but that actually it kind of irritates me because in later courses and what we've seen already, a creates a reflection whether it opens up or down or stretches and shrinks. So I'm going to keep the a kind of what it does in before, and I'm going to use b to the x. Now the good news is everything in this book, when we're introducing it to you at this point, a equals 1. So it's going to be just b to the x minus h plus k. We're not going to do anything complicated with the a yet. We could. I could kind of have those discussions, but they're not going to do anything complicated with that yet. Definitely in a pre-calc you would see that. So it bothers me that the book does a to the x minus h plus k, because in later books you're going to see b to the x minus h plus k. So I'm going to just call this part b. Plus I like that it's the b because it's the base. We're doing a base raised to an exponent, so it's nice when those things line up. So the b is the base, and there's a couple types. If you don't know what this graph looks like, no big deal. We know how to plot points. So I'm going to take all of these x's and stick them in place of the f of x, in place of the x. So f of negative 2 would become 3 to the negative 2. Please don't make that negative 6. Don't make it negative anything. It's 1 over 3 squared, or 1 over 9. Now that's not going to be pretty, but that's okay. It's going to give us an idea. 3 to the negative 1 is going to give us 1/3. 3 to the 0 is not 0. This graph actually never crosses 0, so don't get too carried away. Anything to the 0 power, you have to remember, is 1. 3 to the first is 3. 3 squared is 9. That's enough to get a quick sketch. See, when the b is greater than 1, we end up with an exponential growth, which means going to the left, the numbers get smaller. 1/3, 1/9, 1/27, 1/81. The idea is as I'm going to the left, it's getting smaller, but as I go to the right, 0 gives me 1, 1 gives me 3, 3 gives me freaking like 9, right? The idea is as it goes to the right, it shoots, it rockets up exponentially. And as it goes to the left, as I raise 3 to a negative exponent, it gets closer and closer to 0. That's an asymptote, in fact, right? That means that that y will never equal the 0. It's going to stay there at 0. Well, what happens if the base is a fraction between 0 and 1, or a decimal or a smaller number, right? No big deal. I can do 1/3 to the negative 2. Does not make it negative anything. It flips it to become 9. 1/3 to the negative 1 flips it to become 3. 1/3 to the 0. Anything to the 0 power is 1. 1/3 to the first is just 1/3. And 1/3 squared is 1/9. So what happens when that base is between 0 and 1, when it's a smaller base? Well, as we go to the left, negative 1 gives us 3. Negative 2 gives us friggin' 9, right? 0 still gives me 1. 1 gives me 1/3. 2 gives me 1/9. Then 127, 181. The idea is this time, as it goes to the left, it rockets up. And as it goes to the right, it gets closer and closer to. In fact, y still will not equal 0 here. It has an asymptote. So if I am multiplying by large numbers, it rockets up. If I'm multiplying by fractions, it gets closer to 0. That's the kind of the right side. As I divide by large numbers, it gets closer to 0. As I divide by small numbers, it rockets up. So this is kind of our relationship between these two. You're going to either have a base greater than 1, and it'll look like this, or a base between 0 and 1, it's going to look like this. So let's summarize this real quick. If the base is greater than 1, it rockets up. You get not 1/6, that's 1 comma b. If that bothers you, then make it a capital B. I don't really care. Okay. 0, 1, and negative 1, 1 over b. And that's going to be enough to see what this graph looks like. If it's between 0 and 1, you just get kind of a flipped relationship there, where 1b now gets smaller, so that's the side that gets closer to 0. But these are really the only 3 points you need to graph this. Negative 1, 0, and 1. What else do we add to that? Well, we're going to have some shifting. We're going to have some H, we're going to have some K, we're going to have some A. Okay? Well, really, once again, the A is not going to show up much. So what do you have to know? H is the horizontal shift. So when I have H is our horizontal shift. It's always opposite, just like it's been. So the idea is, if H is positive, it shifts to the left. If it's negative, it shifts to the right. It's opposite. The K, the vertical shift, goes up, negative goes down. So there's going to be our function. Those are all of our pieces that we need to know. Let's practice it. Graph 6 to the x minus 4. My short answer is going to say no, because just like we did with parabolas, this would be a lot easier to shift if I knew what the parent graph looked like. If I ignored any shifting, if I ignored that 4, all I would have is 6 to the x. If I asked you to graph 6 to the x, that'd be really easy. 6 to the 0 would give me 1. 6 to the first would give me 6. And I said we should do a negative. 6 to the negative 1 would give me 1/6. A little tiny number there. This is what the parent graph looks like. This is not my final graph. We're close, right? This is what the parent looks like. All I've done is ignore the shifting because I know that doesn't change the way the graph looks. Now, how do I get the final graph? Well, we shift it -4. Is that an H or a K? Since it's not with the X, that's a K. A K of -4 means the graph will shift 4 vertically down. So I take each of these points and they go down 1, 2, 3, 4. 1, 2, 3, 4. And this one even goes down 1, 2, 3, 4. Be careful. How low does this graph go? Because if you dip it below this, you actually lose points. That's not correct. Because what you have to remember is that the asymptote also shifts. See, the asymptote was at y equals 0, and that also got shifted down 4. So this horizontal line gets shifted down 1, 2, 3, 4. So now we have an asymptote at y does not equal -4. Sorry about that, sloppy. In fact, the asymptote will always be at y cannot equal k. If a graph gets shifted up or down, so does the asymptote. That's it. So graph the parent, shift it, piece of cake. Let's keep trying. 2x minus 3. 1, what's the parent graph? Ignore the shifting, and I'm just going to graph 2 to the, that's easy. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. I've got 3 points. The right side, because this is greater than 1, shows me that that's where it's rocketing up. The left side's where it's getting closer to 0. 2. What does that -3 do? Is it an H or a K? Well, it's an H this time, right? Opposite means if that's a -3, we shift H +3. 3 to the right. It's opposite. So each of these points gets shifted now. 1, 2, 3 to the right. 1, 2, 3 to the right. And even this one. 1, 2, 3 to the right. Where's our asymptote? Well, the asymptote was here. If it gets shifted to the right, it doesn't actually change. So there is no K, there is no vertical shift. So the asymptote stays at y does not equal 0. Keep that in mind, there is no K, so we would say K equals 0. Okay? Let's see if we have one with a fraction. Nope, we don't. Let me come up with one. That's sloppy of me. How about just how would we graph this? Well, first, parent graph would be, should be in parentheses, but there we go. So the idea is we ignore that shifting. What is 1/3 to the 0? What is 1/3 to the first? What is 1/3 to the -1? This is our parent graph. These same 3 points that I do just from the parent graph were -1, 0, 1. 3, 1, 1/3. Those 3 points. All I have to do now is shift the graph. This +1 is a, so we're going to shift it opposite, 1 to the left. Every point gets moved, 1 to the left, 1 to the left, 1 to the left. And there is our final graph. Once again, asymptote does not get shifted up or down, so y just cannot equal 0. So that's it. That shouldn't be terribly complicated. Exponential functions are generally pretty easy to graph. We're going to be building on this, so make sure you knock this section out.